Hey there, math fans. A student in my calculus course earlier today asked me to review the exact values of trig, and we talked about how to remember what the 30, 45, 60, 90 values of sine and cosine, and we talked about tangent and inverse tangent and those things. Throughout the day, I've been thinking about this, and I remember when I was about the age of my students thinking the following. I thought, well, we've learned all these trig identities, in particular these half-angle identities. Maybe we can use them to find some other things. And what I mean by that is, let's just take, let's take cosine for example. Cosine squared of x is one of our identities, equals 1/2 1 plus cosine of 2x. And I was like, hold on, why is it that we only talk about 30 degrees and 45 degrees when you could easily just put 30 degrees right here? Or equivalently pi over 6. And if you put pi over 6 there, then you get 15 degrees. X is pi over 12. Did you know that we know the cosine and sine of 15 degrees? And when I actually thought I was like, oh, I think discovered something. Obviously, this has been talked about before. These are just the angles people like to talk about the most and are easiest to construct. But this might be surprising if you haven't thought about it. So cosine of pi over 12 must be the square root of 1/2 of 1 plus the cosine of pi over 6. And we know the cosine of pi over 6, it's root 3 over 2. So the cosine of pi over 12 is the square root of 1/2 of 1 plus the square root of 3 over 2. Which we could probably simplify a few different ways. I don't know the typical way people write this because it's not something I deal with that often. Maybe if we factor out that 2. So if we factor out the 2, it'll make this a 4. Let me do that in 2 steps. 1, 4, square root. Since I factored out a 1/2, this will have to be 2 plus the square root of 3. Okay, impress your friends. Cosine of pi over 12, which is 15 degrees, must be equal to 1/2 of the square root of 2 plus root 3. Please let me know if I made a mistake there, because I just am kind of putting this together quickly just to get it out of my head. I could do a lot more research because these are not the only angles that are known. There's a long history of this, which angles you can construct with the straight edge and compass. This is just one. There's nothing that stops you from continuing to go except sanity. So you could say, well, what if I now put pi over 12 here? That's going to give me half that, so it's going to give me 7 points. So cosine of pi over 24, which is 7.5 degrees, I also know it's going to be the square root of 1/2 of 1 plus cosine of pi over 12 of this. So it's 1/2 of the square root of 2 plus the square root of 3. And then you can keep going. If you wanted cosine of pi over 48, you could get it. You can keep dividing by 2 forever. So you can get really close. You can get a lot of cosine values. And you can also get like the ones in between, because we could have started at 90. So there are a bunch more exact values. So you might say, why have you never heard of this before? And that's what I thought when I was a student. It's just because this is kind of messy. And we like to start with angles that are a little bit nicer. Once we get beyond these give us enough that we have plenty to talk about. But that's it. And once you know cosine, then you also know sine, and you also know secant, and you know tangent. So there's a whole bunch of angles we know, not just these angles. You can divide any of these angles, the pi over 3 and the pi over 4 and the pi over 6 by 2 as many times as you want. So that means we can handle anything that's like 2 to the k times 3 or 2 to the k times 4. So we can essentially handle any power of 2. So you can do pi over 256, for example. We can handle anything that looks like this. But it's not just those, because you also have like sum identities. So you can add these together. There are things you can't easily construct. That kind of involves working with fractions. But I think I will stop the video there and ask, if this interests you, do you want me to dig deeper? I could make a video where I go further, but I've already made too many videos this week. So I just thought I would stop and make a little comment on that, because I remember being surprised the first time I ever saw this, and some of my students might be surprised, that we know cosine and the exact values of cosine and sine at many other values. For example, cosine of pi over 24 is the square root of 1/2 of 1 plus 1/2 the square root of 2 plus the square root of 3. How many square roots can you get in the same expression? Well, it's going to get worse if you keep going. All right, hope you found that interesting.